Hello everyone, I am Vamshi Pratap from Civil Department, Assistant Professor in St. Martin's Engineering College. Today I am giving a video lecture on cement, types of cements and physical properties. Cement. Cement is the main ingredient in the concrete. It is a binding agent which uh, which makes the concrete has a binding material by its adhesive and cohesive properties. Okay. Next, it is an main ingredient in concrete and mortar. Concrete is in concrete. Cement is one part of the cement and one part of coarse aggregate and one part of sand. In that one part means one part, and cement is mixed with water to form a carbonation reaction which binds the aggregates like rocks and fine aggregates. This is the picture of cement. And the word history about the cement. The word cement is derived from the Greek word cementitious, and in that previous years lime and clay has been used as a binding properties. In that, in 1824, Joseph Asbden, England, invented the Portland cement. In that, best example is Python in Rome is the best example to see the cement structures and the main ingredients, cement ingredients. In that we have lime. Lime is 67 to 62%, and in that silica we have 17% to 25%. In this we use maximum is 22%. In that alumina is 5 to 8%. In that, in the ingredients, calcium sulfate, gypsum is used as a 0.3 to 0.5%. In that, iron oxide, Fe2O3 is 6% to iron oxide 6% to 3%. In that, magnesia 2% to 3%. 2% to 3%, and sulfur trioxide SO3 which is 1% to 3%. We use the 1% only. Okay, we discuss into the ingredients. Limestone is the main ingredient in cement, and limestone is derived from the sedimentary rocks made up of calcium carbonate CaCO3. In that, okay, next, alumina. Alumina is derived from the bauxite or ore of aluminium. Aluminium gives cement and its quick setting properties. However, too much alumina can give us weaken the cement. And now about silica, SiO2 reacts with calcium to form a dicalcium silicate and tricalcium silicate C3S. Okay, C3S, which strengthen the cement. However, too much silica slow down the setting properties. Now about calcium sulfate, present in the form of gypsum CaSO4 2H2O. Gypsum slows down the setting process, which means of the consistency of the cement. Next, iron oxide. Iron oxide gives its color and acts as a flux, and it is also reacts with calcium and aluminium to form a aluminum ferrite, which strengthen the cement. And magnesia gives cement color, but too much can make it unsound. Okay, next, sulfur. A small amount of sulfur can make the cement sound. In that, sound means expansion. Sound means expansion of the cement. However, it gives the consistency, strength and durability of the cement. And next, the process of manufacturing of cement. The manufacturing is, first step is quarry. Quarry means rock quarries are blasted from the explosive to get the limestone, calcium carbonate and clay. These raw materials are transported to the crushing units to be crushed into smaller particles, which are then grinding. The above materials are transferred to the grinding section. There it mixes with additional minerals like such that silica, iron ore, etc. with the required amount of cement. Next, in various groups, grinding are used to ground above mixture into a homogeneous mixture. In that, next part is burning. In burning, this mixture is fixed into the kiln that burns it at extreme high temperature, which is 1500 to 1400 degrees. In that, it burns like a boiler. Next, it is transferred and assembled as a pebble sizes, which is transferred to a storage. In that, the clinker is cooled down the process after boiling in soil. Later, ground to a fine powder, which is we get the cement with a grinding mills. Then the packing, this is the main thing. The cement is packed into different types of packings and dispatched, which is shipped by bags or vehicles to the sites. And next, this is the flow chart of manufacturing of cement. First, we bring the rock from the raw materials from the site after explosion of quarry. In the quarry, which is calcium carbonate, then it is crushed into small pebbles and transferred to the crusher machines. Next step, the crusher machines are crushed into smaller particles, then transferred to the grinders, which is grinder used for a mixing purpose. Mixing purpose, which is mixed by aluminum ore or iron ore. Then the raw materials are washed in a kiln, which is to remove the waste particles. After that, raw materials plus 30 to 35% water is added to the raw materials. Raw materials slurry is mixed in the storage tank. In that kiln, calcination is done. After mixing with water, calcination is hydration process will continue. Hydration is nothing but heat. When cement is mixed with water, the heat of hydration will take place. The heat means in that, then next it is transferred to the clinkers, which will form the lumps or pebble sizes in the clinkers. This is one of the manufacturing form. We call it as wet process. And another process is dry process. We have two manufacturing process. In that, one is wet process and second one is dry process. In that, addition of gypsum and in the grinder with ball mills, what will it do? It will set the cement. And then the final part is we will get the ordinary Portland cement, which is simple as Portland cement, nothing but Portland cement. Next, we will get types of cements. Basically, types of cements are two categories. One is hydraulic cement and the second one is non-hydraulic cement. Hydraulic cement is formed by reaction of powdered cement with water. You can use it any type of construction under the water or normal structures. And next, second one is non-hydraulic structure cement. Non-hydraulic cement sets its adhesive properties because of due to carbonation. Okay, you can see it for use for various projects other than the underwater construction projects. And next, hydraulic cement is the most commonly used cement and it is a type of hydraulic cement preferred choice for architects, engineers and contractors. The primary reason is its ability to harden quickly, which is in that concrete means it have the mixed proportions, which is like one part of cement, one part of sand and another part of aggregates. Like concrete means having ratio of mixed proportions, like in this M20 grade, which is 1:1:2%, and 1% is cement and 1% is sand, nothing but fine aggregate, and 2 parts is coarse aggregate, nothing but rocks at the size of 20 mm to 25 mm. We can use up to 25 mm for the M20 grade of concrete. In this, okay, in this we use we'll study about the ordinary Portland cement, nothing but types of cement. It is one of the Portland cement mixed with gypsum. It forms ordinary Portland cement, nothing but ordinary Portland cement. It is a both mixture of calcium clay and pozzolana, which is a fly ash, and it is used for all type of constructions including marine and hydraulic structures. Marine structures are occurred in near oceans or river beds, and hydraulic constructions are nothing but high-rise buildings, which are nowadays we are seeing with high-rise buildings. Next, rapid hardening cement, nothing but the initial and final setting of the cement is same. Basically, initial setting time is 90 minutes, which is the cement get hardened within the 90 minutes, and for the final setting time it will take 6 hours, 10 hours, like 600 minutes to get the hardened. For this rapid hardening cement, both are equal because it attains high strength in early days, nothing but usually we get a 7 days or 14 days or 28 days strength, but it gets quickly in early days in the rapid hardening cement. It contains high percentage of tricalcium silicate to extent about 56% in this. Okay, because of the high percentage of tricalcium silicate C3S, okay, C3S, we will get the high strength in the early days up to okay. Next, sulfate resisting cement. In this cement, the percentage of tricalcium silicate C3A is kept to below 5% only. Okay, and it results increasing the against sulfates. Sulfate means soluble liquid salts. And next, sulfate resisting cement. In this cement, the percentage of the tricalcium aluminate C3A is kept below 5% because of in the increasing the power resistance against sulfates in the cement. And next, low heat cement. Low heat cement, nothing but it considerable heat is produced the setting time of in order to reduce the amount of heat, nothing but which is low heat cement means to reduce the heat of the cement. This type of cement used, and it contains lower percentage of tricalcium aluminate. Because of this tricalcium aluminate, okay, it contains the low heat and about 5 percentage high percentage of tricalcium silicate, nothing but dicalcium C2S. If you have high percentage of this, we up to 46% in the cement, then it will get the low heat cement. After that, pozzolana cement. These are the types of cements which are used in the construction purposes. And pozzolana is a volcanic powder, and it is available in the near Italy, Vesuvius. This type of cement is used to prepare mass concrete for a clean mix. Mass concrete means we can use in the gravity dams or heavy structures in the footings or basement. It is also used in the sewage works underwater structures. Okay, these are the pozzolana cement. Pozzolana cement. Pozzolana is a volcanic powder which is found near Italy, Versailles place, and this type of cement used for mass concrete, which is for gravity dams or structure basement, and this is used only for some types of sewage concrete works under the water. And next we'll talk about colored cement. Colored, the type cement is color may be obtained by mineral mixing pigments with ordinary cement. These types of colored cement are widely used for finishing of floors and external surfaces, artificial marble, windows, and structured textured panels. And white cement. White cement is prepared from such a raw materials which doesn't have any pigments or color particles and free from iron oxide, which is used the white cement. It is a white in color and used for floor finishing and plastering work and the ornament work, etc. And physical properties of cement. Fineness. One of the fineness is it is the size of the particles of the cement. The desired fineness can be used in the achieved by the adjusting grinding of the clinker. Grinding is adjusted in the manufacturing of cement. In that, soundness is the ability of the cement to resist shrinking upon hardening. The Lee Chartier test and autoclave test are the best to determine the soundness of the cement. And in this, consistency is the main important topic in the cement, which gives the paste viscosity to form the or to have the ability to flow the concrete while concreting the concrete. And setting time. The setting time of cement is defined as the time required for concrete to change from its liquid state to plastic state, and later on from plastic state to solid state. By this we will get the final setting time. And compressive strength and flexural strength and tensile strength of the concrete cement is measured by to know the ability of cement after an elongated period. For a long time of period, we will get know the compressive strength of cement. And next about specific gravity. Mostly specific gravity cement have 3.15, which is to give us the specific gravity, which is 3.15, and cement mass reference for which is usually what has the replaced with the water. And next about field test of cement. This is the main test which we can do anywhere in the field after observing with by some field test, which is date of manufacturing. By date of manufacturing, the strength of the cement is reduces with age. The date of manufacturing of cement bag should be always checked before bringing to the construction site. And next, cement color. The color of the cement should be uniform color, and it should be a only one color, which is gray color with a greenish shade. And in this next, hard lumps are formed. We should keep free from the hard lumps because it is formed by absorbing moisture in the from the atmosphere. And next, temperature inside the cement bag. After, while putting hand in the cement bag, you should feel a cool temperature to know the good cement. If you have the high heat on the cement bag, you should know about the adulteration of the cement, which is harden of the cement. And next, smoothness. When you take the cement into the hand and rub between the fingers, you should feel a smooth feel before. Otherwise, if it feels a rough condition, and it indicates the adulteration with sand. And next, water sinking test. And take some amount of cement and throw it in the bucket of water. If the cement sinks slowly to the water, then it will have the good cement. Otherwise, it is a what will get adulteration of the cement. If it is not flowed or it will sink immediately, the quality of the cement is very bad. As you see this diagram picture of in the panel, IS code, you should mention this IS code as per our conditions, and you should have a hook face and ISI mark on the cement bag, which is checked by batch number at the time of batching when it is manufactured, or MRP check when but the price of the cement bag, and brand check which company is used. I am taking the example of Ambuja cement bag. In that you will see the manufacturer name and trademark about the company, and weight of the cement and grade of the cement. Usually we have a grades like, in cement we have the grades like 33 and 53, 43, which is known as the compressive strength of the cement. Nothing but in that we have 33 grade and 43 grade and 53 grade, which is nothing but compressive strength, which means after the 28 days the compressive strength should be 33 megapascal for a 33 grade, and for the 43 grade you should have a 43 megapascal after 28 days completion. And for the 53 grade, the compressive strength Compressive strength is 53 megapascal for a 28 days to get us know the value of the cement. And next about the we'll study about the this is the picture of about cement aggregates and tests on fresh concrete, which is nothing but slump cone test. This is the main test which can be performed in the site or in the laboratory, which is nothing but slump cone test is to check the workability of the concrete, which is nothing but you have the apparatus like cone shape which have 20 centimeters on the downside, 10 centimeters on the upside, and the height of the cone is 30 centimeters, which can be used for, and you have a handles over here at a distance of 10 centimeters from the above part. And in this, the concrete is placed at 4 layers. 4 layers. In the 4 layers, at every layer you have 25 centimeter and tamped with tamping rod after at 25 blows for every layer. We have the 4 layers at every 25 blows. After removing the mold, you will get the slumps like true slump, and one is shear slump, and one is collapse slump. Collapse slump, nothing but we have the mixture of water is more in this. Shear slump, we will get the consistency by the slump cone test, which is nothing but performed in the laboratory or in the field. Next is we have the compaction factor test, which is nothing but, as you see, this is the true slump which we have the exact height at the experiment mold, and this is the collapse slump which is fall at the collapse, and we have the tamping rod at a 60 centimeters and 16 diameter. And we have the next test is compacting factor test. After mixing of the concrete, we pour into the upper hooper, and after that we slowly remove the trap door at the downside to free fall to the lower clamp. In that, after that, we will remove the slower clamp, hopper trap door to fall in the cylinder, which means after taking this cylinder by weight, we keep as it as a W1, and the next we perform with a compacted cylinder which is nothing W2, and the empty cylinder is W. Empty cylinder is W. In that, the formula is for compaction factor W1 minus W and W1 minus W2 minus W into specific gravity of the cement. In that, we'll perform the test about the compaction factor test. We'll have the video on the. This is slump cone test. As you see, the above picture shows the 10 centimeters top the mold, and below you will have the 20 centimeters, and height of this is 30 centimeters. This is a true slump after removing the mold, after the removing the mold. And we have the, this is how the slump is measured. Slump is measured by 77%. 77 means low slump, low workability, and after 20 hardened centimeters, 100 centimeters up to, you will get the 20 height of the slump with the, as you see, 20 to 75 centimeters low workability. In this, we can use it for mass concrete or highly reinforced concrete, and in that 50 to 100 centimeter height means, means it is a low medium degree of workability, which is heavily reinforced and used for a slip work, which is for beams and columns or pumped concrete. And for the slump 100 to 150 which is degree of workability is high, we can use it for trench filling and in situ filling, which is nothing but high workability. And the next is greater than, if the slump is greater than 150, the workability of the concrete is very high, which is temporary works or terrain works are used. In this, we will observe by the slump cone test how much the or the fall of the concrete after removing the mold, we will get the degree of workability in the concrete. And thank you. This is about cement and properties. Thank you.